friends, today in this video I am going to talk about Lewis dot structure. First I will talk about Lewis dot symbol. What is Lewis dot symbol? Valence electrons determine an element chemistry. Lewis dot symbol represents the valence electrons of an atom as dots arranged around the atom symbol. Most useful for main group elements. You can see the Lewis dot symbol of the main group elements. Hydrogens, lithium, sodium, potassium, rubidium, cesium, francium, 1 electron. Barium, magnesium, calcium, strontium, barium, radium. You can see the 2 dot is here. And boron, aluminum, gallium, indium, thallium. 3 electrons dot structure. Carbon, silicon, germanium, tin and lead. 4. Nitrogen, phosphorus, arsenic and antimony, bismuth. You can see the 5 dot. Oxygen, sulfur, selenium, tellurium, polonium, 6 dot. Chlorine, bromine, iodine, styrene, 7 electron. Helium, neon, argon, krypton, xenon, radon. You can see the 8 and 2. So ये जो electrons है ये Lewis dot symbol of the main group elements आपको दिमाग में रखना है. Now write Lewis dot symbol for the following. Nitrogen H2 minus K plus. आप इसको लिखिए. Write Lewis dot symbol for the following. You can see for nitrogen 5 electron, sulfur 2 minus, so 2 electron. Calcium plus, so calcium plus. So ionic bonding. Ionic bond electrostatic force that pulls oppositively charged particles together form between cations and anions. You can see the examples: sodium 1 electrons and chlorine 7 electrons. So Na plus and Cl minus 8 electrons. So this one. So electron affinity 1 and electron affinity E is equal to 496 kilojoule per mole. So 349 kilojoule per mole and 147 kilojoule per mole. So melting point 801 degrees Celsius and heat of formations is minus 410.9 kilojoule per mole. Now microscopic view of sodium chloride formation. You can see this is the sodium and chlorine. If it is joined together, then it becomes sodium chloride. So lattice energy. What is the meaning of lattice energy? The energy required to completely separate 1 mole of a solid ionic compound into gaseous atom. यहाँ पर आप देखें ये सोडियम क्लोराइड का क्रिस्टल्स है. ये इसको जब तोड़कर अलग अलग कंप्लीट करते थे इसी को लैटिस एनर्जी कहते हैं. जितना अमाउंट इसमें तोड़ने में लगता है उसी को लैटिस एनर्जी कहते हैं. सोडियम क्लोराइड, सोडियम प्लस और Cl माइनस. सो लैटिस एनर्जी हियर प्लस 788 kilojoule per mole. Because they are defined as amount of energy, lattice energy are always positive. Now Coulombic attractions. If you have the two particles Q1, Q2 divided by D2, so force directly proportional to Q1, Q2, D2, Q amounts of charge, D distance of separation. So lattice energy, like a Coulombic force, depends on magnitude of charges and distance between the charges. Now you can see the lattice energy of alkali metal iodide. So you have the lithium plus and I minus. I minus size you can see 2.20 angstrom and lithium छोटे होते हैं, iodine minus बड़े. So इसका force जब आप निकालेंगे तो largest lattice energy निकलेगा. And sodium plus and I minus में देखिए intermediate lattice energy and K plus I minus में smallest lattice energy. This is the. Now ionic radii sum for the lithium fluoride and magnesium oxide are 2.01 and 2.06 angstrom respectively. Yet their lattice energies are 100,030 and 3795 kilojoule per mole. Why is the lattice energy of magnesium oxide nearly 4 times that of lithium fluoride? You can see the calculation. Lithium 0.76 angstrom, fluorine 1.33 angstrom. Now you can see the F is this much. So smallest lattice energy. In case of magnesium oxide, you can see 3819 kilojoule per mole. So know the Born-Haber cycle, a method to determine the lattice energy. So you have the lattice energy like this: heat of formations, heat of formations, heat of formations, and ionization energy of sodium. So if you have the sodium chloride solid, means sodium plus gas and E and Cl gas, and then they are producing from the sodium to sodium plus gas and from the Cl2 to Cl minus and Cl gas, and then combined together they are forming lattice energy. So you can see in case of calcium oxide, calcium first solid, it become gas and then gas. If you have the oxygen half O2, then it will O2 O gas and O2 minus. So if you calculate all energy involved in calcium oxide, you will get the lattice energy 3398 kilojoule per mole or 3398. Now covalent bonding. My friend, atoms share electron to form covalent bond. You can see hydrogen share one electron forming H2 molecule. In forming the bond, the atoms achieve a more stable electronic configuration. So octet or 8 is a magic number of electrons. You know the octet rule. Atom will gain or lose a share electron to acquire 8 valence electron. Like sodium loses 1 electron, chlorine gain 1 electron. Hydrogen sharing 2 electrons with the oxygen for the formation of covalent bond. Lewis structure, you can see hydrogen have 1 electron forming H2 molecule. Cl have 7 electron sharing 1 electron forming the Cl2. So shared electron is called to bond, and non-bonding valence electron is lone pair. Now multiple bonds. The number of shared electron pair in the number of bonds, you can see in Cl में 1 electrons bond, single bond. If you have the carbon dioxide, you have 2 double bond between carbon and oxygen, and you have nitrogen, between nitrogen triple bond is there. So bond length and bond strength. Bond strength means triple have the higher strength than double than single, and bond length, you know, single have greater bond length than double than triple. So bond strength, you can see the nitrogen single bond, double bond and triple bond. You need bond length, you see the decreasing, and bond strength, you can see the increasing. Now electronegativity and polarity. Non-polar covalent bond, electrons are shared equally by 2 bonded atoms, and polar covalent bond, electrons are shared equally by 2 bonded atoms. You can see electron density distribution. In the H2 and HF, they are forming NF. So red high electron density, green immediate electron density, and blue low electron density. That's why that is the polar H, partially positive charge and partially negative charge on fluorine due to electronegativity. So electronegativity, ability of an atom to draw shared electron to itself. For more electronegative elements attract electrons more strongly. Relative scale, relative to ionization energy, electron affinity, unitless, smallest electronegativity of cesium 0.7, and largest electronegativity fluorine. So you can see the electronegativity and Pauling scale. For hydrogen 2.1, lithium 1, sodium. So from top to bottom it is decreasing. From left to right it is increasing. Now variation electronegativity atomic number. You can see how it is increasing and decreasing. Now polar and non-polar bond. You can see the H2 and HF forming NAF. So non-polar covalent bond, HF is polar covalent bond and forming ionic. So dipole moment and partial charges. Polar bonds often results in polar molecules, and polar molecule possesses a dipole-dipole moment that is represented by mu. The quantitative measure of dipole, you can see the Q1 and Q2. HF, hydrogen has partially positive charge and fluorine has partially negative charge. Mu is equal to here Qr. So SI unit coulomb meters and common unit dBm. So drawing Lewis structure. My friend, drawing a skeleton structure with the central atom being the least electronegative element. The valence electrons add one electron for each negative charge and subtract one electron for each positive charge. Subtract 2 electrons for each bond in the skeleton structure. Complete electron octet for atom bonded to the central atom except for hydrogen. Place a star electron on the central atom. Add multiple bond if atom lack an octet. So what is the Lewis structure of nitrate? You can see they draw the skeleton structure with the central atom being the least electronegative. You can see some valence electron add one to each negative charge and subtract one for each positive charge. So 1 into 5 plus 3 into 6 plus 1, 24 electrons, and subtract 2 for each bond in the skeleton structure and a 6 electron. And then this is the Lewis structure. So other Lewis structures. Now friend, Lewis structure and formal charges. From here I will discuss in my next video.